Hello dear students. In today's video we will learn about triangles. The classification of triangles on the basis of its sides and its angles. And then we will learn about the median and altitude of a triangle. And finally we will learn about the exterior angle property of a triangle. In the earlier classes, you have learned about lines, line segments and angles. And also a little about triangles. But in this chapter we will put our focus entirely on triangles and its properties. So, let's start with what is a triangle. A triangle is a two-dimensional shape which is made by joining any 3 points A, B and C on a sheet of paper that do not fall on the same straight line. We can call this closed figure triangle. ABC or triangle. BCA or triangle. CAB. The segments AB, BC and CA are called the sides of the triangle ABC. And the points A, B and C are called the vertices of the triangle ABC. Vertices is the plural of vertex. We can classify the triangles according to the sides and angles. If we classify the triangle on the basis of its sides, we have 1. Equilateral triangle. A triangle that has all the 3 sides of the same length. 2. Isosceles triangle. A triangle in which only 2 of the sides are of the same length, the third one is of different length. 3. Scalene triangle. A triangle that has all the 3 sides of different lengths. If we classify the triangle on the basis of its angles, we have 1. Acute angle triangle. A triangle that has all angles smaller than 90 degrees. 2. Right angle triangle. A triangle that has one angle equal to 90 degrees. 3. Obtuse angle triangle. A triangle that has one angle greater than 90 degrees. Now, understanding more about the triangles, let's learn about the median of a triangle. Here, we have a triangle made of paper. Suppose we have to find the midpoint of this side. Can you tell us how to go about it to find the midpoint of this side of a triangle? We fold the paper in such a way that the 2 vertices of this side cover each other. We will draw the crease. Then the point where the crease intersects, this side of the triangle, is the midpoint of this side. Now, if we connect the midpoint of this side with the opposite vertex, then we will get a median of the triangle. The median is the line segment that connects a vertex of a triangle to the midpoint of its opposite side. Now, let's learn about the altitude of a triangle. Sometimes in a triangle, it is necessary to find the shortest distance between a vertex and its opposite side. But how do we do so? Suppose we are given a triangle PQR, and we have to find its height. That is, we have to find the shortest distance between the vertex P and the side QR. To find this distance, we can make line segments in different ways. But do you think all these lines give us the correct information about the distance between the vertex P and its opposite side QR? Or say the height of this triangle? Think about it. No, not all of them give us the correct information. From the vertex P, to find the height of a triangle, we draw a perpendicular to its opposite side QR, which intersects the side QR at point J. A perpendicular drawn from a vertex to its opposite side is called the altitude of the triangle. Our line segment PJ is the altitude of the triangle PQR. That forms a right angle on the side QR. This gives us the distance between the vertex and its opposite side. That is the height of a triangle. Note: a triangle has 3 medians from each of its vertices to its sides. A triangle has 3 altitudes from each of its vertices to its sides. Moving forward, let us now learn about the exterior angle of a triangle and its property. Consider any triangle, and let's call it Triangle ABC. We know what the interior angles are. But what are exterior angles of a triangle? It's simple. We just have to extend any one side. Say, let us produce side BC to point D like this. Since we have just extended BC to D, it means that BD is also a straight line. That is, the angle ACD is in the exterior of the triangle, which is why it's called the exterior angle. We know these three angles are in the interior. But this time we will look at them with respect to their exterior angle. First, let's look at this angle. We know that it lies in the interior of the triangle. And it is adjacent to this exterior angle. So with respect to this exterior angle, it is the interior adjacent angle. What about the other two angles? Angle A and angle B. A and B both are in the interior region of the triangle and are not adjacent to the exterior angle ACD. They are called as interior opposite angles. Now that we have learned about the exterior and interior opposite angles of the triangle, let's try to derive an interesting relationship between them. Let's name the interior angles of this triangle as angle 1, angle 2, and angle 3, and the exterior angle as angle 4. We already know that the sum of the interior angles of the triangle is 180 degrees. That means angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. Let's name this equation as equation 1. Now look at the angles 3 and 4. We can clearly see that those two form angles on the same straight line. And we also know that angles on a straight line sum up to 180 degrees. So, we can write this as angle 3 plus angle 4 is equal to 180 degrees. Or we can write it down as angle 3 is equal to 180 degrees minus angle 4. Now, name this equation as equation 2. Now we will be substituting the value of angle 3 from equation 2 and using it in equation 1. On solving, we get that angle 1 plus angle 2 is equal to angle 4. Great! We have therefore derived the relation between these three angles. This derivation proves that the exterior angle of a triangle is always equal to the sum of its two interior opposite angles. Now that you have learned about the exterior angle property, let us see a solved example to use the property we have just learned. In the given figure, find the value of x. Let us first mark these angles as angle 1, angle 2, and angle 3 for our convenience. Now, we can use the property of exterior angle and write that angle 1 plus angle 2 is equal to angle 3. Here angle 1 is 70 degrees and angle 2 is unknown, therefore x and angle 3, that is our exterior angle, is 120 degrees. By putting in the values, 70 degrees plus x is equal to 120 degrees. That is, x is equal to 120 degrees minus 70 degrees. Thus, x comes out to be equal to 50 degrees. Easy, right? To learn about more such topics, open the EduRev app where you get video lectures, chapter notes, and MCQ tests for this chapter to solidify your concepts. EduRev also provides you amazing courses for science, social studies, English, Hindi, and many more.